welcome to the jungle. So it's like a little bit of a safari through the JVM landscape. And it might contain some interesting parts that you might not know yet. So let's see at the end. My name is Gerrit Grunwald. I'm working for Azul, as you can see. We do JVMs for more than 20 years. And I'm working there as a developer advocate, meaning doing this stuff. I did a lot of coding in consultancy companies, and I did 10 years of semiconductor and research and development stuff in Asia before I became full-time developer. And then at one point I started doing this developer advocacy stuff. I'm also leading a Java user group in Münster. So if someone would like to speak there, it's a very nice city. Very close, right? We share the 3 first characters. Okay, let's start. OpenJDK. Who knows OpenJDK? Okay, perfect. That's very good. Who has OpenJDK installed on his computer? That's completely wrong. You don't have OpenJDK installed on your computer. OpenJDK is the project on GitHub. What you have installed is a build of OpenJDK. And that's a distribution, and that's a difference. And that's where everything starts, right? People have totally, if they come to a booth at the conference, oh, what JDK are you running? OpenJDK. Okay. Which distribution? What is the distribution? Okay. So first of all, this is a free and open source implementation of the Java Platform Standard Edition, which means Java SE. You probably heard of that. And it has a website, openjdk.org, where you find, it's not the nicest website, but at least there is one. You find a list of all the projects that are linked to OpenJDK or that are part of OpenJDK. And because it's open source, you can also get the source code of OpenJDK. And this is on GitHub here. In the meantime, before it was somewhere in Oracle Mercurial. So I worked for Oracle for a couple of years and it was terrible. So now they finally, I think it came with JDK 16. They changed that to the OpenJDK to GitHub, which is really nice. But that means everyone can get the source code and build the stuff. And on my machine takes a couple of minutes. Doesn't really take that long to build a JDK anymore. It was way longer in the past, which is nice, but that leads to specific problems. First of all, because it's open source, we have lots of contributors here, and you might be surprised to see so many companies. All these companies are contributing to OpenJDK. Oh, I have to change it to X. And many individuals. So there are lots of single persons that contribute stuff to OpenJDK. And this is a good sign. I mean, we see companies like Amazon or ARM or Google, Intel, IBM. It's really huge companies. If they have an interest in Java, it's a good sign, right? Because if they will drop it, then it means Java will go down the drain. But at the moment, it looks quite good and promising for Java. It means it's not a one-man show. So it's not only Oracle. Oracle is, of course, the main contributor, but there are lots of companies that contribute a lot of stuff to the JDK. And it has a roadmap, of course, it has. And when we start, because it was open sourced at the end of JDK 6, so with one of the last updates, at that time it was still Sun. And at that time we had these very long release cycles. So one JDK was 2006, and then JDK 7 came in 2011. It took forever. And the biggest problem with this approach is that when you stick to JDK 6 and then you wait for JDK 7, you wait 4.5 years, and suddenly you get a release with hundreds of features. And it probably took a year to move from one JDK to the next one. That was not really easy at that time. And then we have 3 years from JDK 7 to 8. Still long, but it got better, and JDK 8 was a really good release. And then they changed the release cadence. So, because it means you have to wait multiple years to really work on a new JDK. Before that, there was no chance to work on in-between versions or stuff, right, that you can test. And then they changed it to this release cadence. That means every 6 months, we get a new release, right? And this is different releases, and we will come to that. And tomorrow, we will get JDK 23 already. And Now you can test it every 6 months. And the idea is, we'll come to that in a couple of minutes, that not all of these releases really get support for a long time. Some of them, most of them, only get support for 6 months, and just a couple of them get really long support, like 10 years or something like this. And this is important, especially if you work in a company and you rely on Java. But first of all, some basics. So we have the JDK and we have the JRE, and everybody should know what the difference is. But still, we will see that lots of you won't know some stuff, because that's the Java development kit. The name says it all, development kit, right? This is the Java runtime environment. Who's running a JDK in production here? That's, see, why? But you don't have to compile it at runtime, right? Have you? You have to? Some people tell me they have to debug and all these things. There's a reason why I asked that. Because if you take a look at, first of all, we have the runtime environment. It's just the Java virtual machine and the class libraries. This is all you need to run your application. If you add the JDK, then you also get stuff like the Java C compiler, debugger, Java doc, and all these stuff. This stuff is not needed for running an application. This stuff is needed for developing an application, right? In principle, easy, right? No problem. But who's running, for example, in microservice environments here? Or just a few. But then you know the problem. If you run stuff in a cluster, in nodes, then these days the cloud is really expensive. So every byte counts. If you deploy JDK in production, this is what you should do, right? You should use the JDK in development and in production a JRE, up to JDK 8. And now's the interesting thing, because up from JDK 9, you should use a JLink JRE. Who knows JLink? And who uses JLink really in production? See? And I don't get it. I mean, tomorrow we get JDK 23, and still nobody's using JLink. Who knows what JLink does? Just a few. Yeah, this is not correct. JLink is, the idea is, with JDK 9, the complete OpenJDK project was split into sub-modules. Before that, everything was sprinkled all over the place. So if you use, for example, a class from AWT, you have to drag in lots of stuff. And then what they did with JDK 9, they put everything that belongs together in modules, like desktop module contains Swing and AWT. This is separate. So if you don't need desktop stuff, then you don't need this module, right? This is totally unrelated to modular jar files. This is the different thing. And this is maybe the problem why nobody's using this. The idea of JLink is you take your application, you use JLink and JDEPS, it's also a tool from the JDK. And what it does is it checks your application and checks what modules is your application really using from the JDK. And then it creates a runtime just for your application. And I give you an example why that makes sense. So you have a custom Java runtime for your application. This is a JDK, JDK 2101. And these are all the modules that are in the JDK. This is 69 modules, and it's 340 megabytes. If you deploy JDK, then at least you would need 340 just for the JDK. This is without your application or anything else. Okay. If you take a JRE for the same JDK, this is the number of modules, still 50, but already only 150 megabytes. So it means even with the JRE, you have to deploy 150 megabytes just for the JRE, for the runtime. And now the example that I show you is a push notification server that I wrote in Java. And this is the modules that my notification server really needs. This is 11 modules, and this is 48 megabytes. And this is all what's needed to run my application. And this is a huge advantage. I mean, if you compare this, then I don't get it why people use still a JRE. Because you save another 100 megabytes, roughly, in this case. And I tested with other applications, so you always end up with 50. It can go down to 30, but we did it with a Spring Boot application. It was 70 megabytes, the JLink JRE. So it really makes sense. And the other advantage is if you do this kind of stuff, if you don't have For example, we have vulnerabilities, even in the JDK, right? So that means security issues. If this security issue is, for example, in whatever module, the desktop module, and you don't have it in your JRE, who cares? But if you deploy this stuff, it's there. Right? So it just makes sense to take a look at JLink. It's not really hard to use it. And like I said, your application doesn't have to be modular. You can use the class path application. It's just the JDK which you shrink down to the stuff that you need. Right? So it really makes sense, and it's really easy to use. You can use it with one script in your build process. It just takes, you create the jar, you scan it, create the JRE, and then deploy the JRE with your jar. It could be one step in a script. It's really not a big deal. Okay, that is JLink. Very important. Then we come to distributions. I already told you, you don't use OpenJDK, you use a build of OpenJDK. And unfortunately, it's not like back in the days where we had Sun JDK, and then there was IBM, they had their own JDK. Is someone running here on IBM's JDK, OpenJ9? Okay, yes? Okay. Because everything's different there. This is just partly applicable to the Samaru runtime. Okay, we have distributions, and we have builds of OpenJDK. These are the builds of OpenJDK that we have. You see we have some with crosses. That means this stuff is dead, right? Adapt OpenJDK, probably some people remember that, which is now Tamarin. And it's not the same JDK, not the same distribution. They made a really smart move because the idea was the community builds a JDK, takes the source code and builds it and then provides it for free, like most of these distributions do. And lots of people use that, but they used OpenJDK in the name. And this is licensed by Oracle. So Oracle was never happy about that, and they told them, you will never get the TCK. We will come to that, what this means. The TCK is important for some companies because they are not allowed to use a JDK that doesn't is compliant to the TCK. We will come to this in a second. And that's the reason why we now have Tamarin, because they had to move away from this. And they had to change the name. And what they did with 16.02, that was the last version of Adapt OpenJDK. The next version, they just linked it to Tamarin. If you download on Adapt OpenJDK, you got this one. This is not correct, because that's a different distribution. The one is TCK compliant, this one not. So that was a little bit tricky, but nevertheless they did it. This is a build from it's a community build of the Red Hat JDK, OJDK build. And I think that stopped with 17.03, something like that. So it's not available anymore. So no new builds. And then you see stuff like, who knows Bisheng? Dragonwell, someone? Alibaba? Kona? These are, we don't know it here.
Corretto is from Amazon.
That's from Amazon, yeah. This is from Huawei. It's huge, but not here. But in Asia, this is huge. And this one is Tencent Kona. Tencent is a huge company in Asia, also very big. Dragonwell is in principle the Corretto of Alibaba Cloud, because Corretto is just the JDK from Amazon for AWS, right? Then we have stuff like Oracle JDK, Oracle OpenJDK, and that's the difference. Who's running here Oracle JDK? The Oracle one with the license. Nobody? Very good. This is the OpenJDK that is built by Oracle, the free one that you can download from the website. This one you can also download for free, but I will come to this later on because it's tricky. This one is free, but you have to sign up. So you need an account, otherwise you can't download. The rest of the stuff is free. You see, except Platform Prime, this is from Azure, this is not free. And then you see Samaru and Samaru Certified. That's another interesting story here. It's in principle the same JDK. The one is certified, that means it has the TCK. We will come to the TCK, what it means. The reason why they had to do it is, it's IBM. Oracle doesn't like IBM. So when IBM said, oh, we would like to have the TCK, then Oracle said, no, you have to pay for it. Okay, so they made Samaru certified. This one is TCK compliant, this one not. Same thing. For this one, you have to pay as a customer because they have to pay, which is really strange. This is the Oracle strategy. But okay, that's the way it is. Okay. These are all builds of OpenJDK. So these companies take the source code and build it, give it a name, like Corrado, like Zulu, and then give it away, mostly for free. Okay, just keep that in mind. It's around 20. And then we have builds of GraalVM, right? Because this is also open source. And there we have Gluon GraalVM, GraalVM Community, which was GraalVM CE, then GraalVM, which was GraalVM Enterprise. Liberica Native Image Kit, this is from Belsoft, and Mandrel is from Red Hat. This is a one-to-one copy of the same GitHub repository, they just name it Mandrel and build it, but it's one-to-one copy, there's no difference. Liberica is a different one, so they add stuff. Gluon is based on GraalVM, but they also add things, and this is Oracle, this both. But they also have some special features in it. So the question is which one to choose, right? So to make a decision, you have to compare stuff. You need to know the differences between them. And we have differences in the terms of support. I will explain that. The update strategy, the compliance, that's the TCK stuff, cost, and performance, right? These are the differences we will take a look at shortly. And term of support, this is what I already mentioned. Who knows short-term support versions, STS releases? Someone ever heard about that? Tomorrow we get a JDK 23, which is a STS release. It's a short-term support version.
21st is the last, I think.
21st was this one. We have long-term support versions, right? Remember, we had all these different releases now, and you can't really support all of them for years. It would take too much effort. So they decided to just take a couple of them, right, and give them a long-term support. If we take a look at JDK 9 down to JDK 21, so in the meantime, like I said, tomorrow we get JDK 23, then the white ones, these are STS releases, and they come out every 6 months, and they only get support every 6 months. That means 2 versions. JDK 9, JDK 01, 901, 902. Then we get JDK 10, 1001, 1002. Then we got JDK 11. This is a long-term version. Long-term versions, they get updates for years, like for 10 years or longer, right? This is the so-called LTS releases, where Oracle said there is no LTS release. Well, there is, as you can tell. And you see they changed the LTS cycle, because here it was quite long. Between JDK 11 and 17, we had a couple of years in between. So in the meantime, the problem is if you have an STS release with 6-month support cycle, here, for example, there was, for the people that know JavaFX, there was a JPackager tool. That means you can create a native executable that calls the jar file. It's not like the native image. And this came with JDK 12. If you need this for your application, then you have to switch to JDK 12. But you only get support for 6 months. After 6 months means you have to switch to 13. Then again, 6 months later, you have to switch to 14. Otherwise, you don't get any updates anymore. And this goes on until you get to JDK 17, and then you can stay on 17 for a long time because you get the security updates. This is the strategy. And that was too long here, right? Because the problem with these short-term support versions is you get new features in these versions, and they might fail. But you only get 2 updates, and then you have to update to the next one. And I don't know if who did updates from one JDK to another one in a company here. It's lovely, isn't it? And these days it's way easier, but it was a mess in the past, because you update, suddenly stuff breaks. Then you have to figure out what breaks, you have to fix it, and all these things. It takes forever. But sometimes you have to, because you don't get any support for the older version, right? That was the problem here. So they changed it. So this is now okay. So we have 3 STS releases, and then we get the next LTS, which then gets a long time support. Like I said, I think it's even longer in the meantime. But if you go to JDK 11 till 2032, you get still updates. The support is security updates. and bug fixes, right? This is what long-term support means. And for all the others, for the white ones, you only get 2 versions. Okay. Yeah, like I said, STS only get updates for 6 months, LTS for years. And that means not every distribution gives you STS and LTS releases. Some of them only have LTS. I think Microsoft, they had 19, I think, was the only STS that they have, because there was a feature in there that they needed for Azure. But everything else is only LTS. They have 11, 17, 21, and then the next LTS. That means you can't really test stuff in between using this JDK. Right? So these are the differences you need to know. In development, you can use whatever you like, but in production, please stay on the LTS release. Right? This is for security reasons. And that leads me to updates, because this is also interesting. Who knows what a CPU is? Critical patch update. It's so funny, right? Nobody knows. Who knows what a patch set update is? Who downloads updates from the internet for the JDK? All of you somewhere, right? This is PSUs. You get PSU updates because they are for free. CPU updates you have to pay for. And the difference is the CPU update contains fixes only for vulnerabilities and critical issues, and that's it. Really just fixes. The PSU contains the CPU and then adds also fixes for non-critical issues, and they also add little new features, tiny stuff, not something like Loom or streams, really tiny things. And the PSU is the stuff you get. So you might think, okay, I'm safe because it contains the CPU, right? Yeah, okay, I will show you why this can be a problem. Because these new features can introduce problems. And we get 4 times a year, we get these updates. And this is, for example, 1702. That was in January. This is usually in January, and then we have every 3 months. 1702 PSU, which contains the CPU, and the CPU that only has the CPU part, right? Only the fixes. So in April, 1703 came out. How it works is this one get new fixes and the features. But this one is based on this, and it has only the fixes, not the features. The CPU is always 3 months behind the PSU. And the reason for that is, once this is out and everybody of you download the new version, you should, because it contains security fixes, then you have 3 months where this stuff runs in production and you get bug reports in that you can fix. And when you get out with 1703, you can fix all these issues that happen in these 3 months in production that you didn't find. And then you come up with the 1703, which is bug-free. Right, that's the idea. And then the same happens the next time, which is in July. 1704 gets the fixes and features, and this one again takes the 1703 and only fixes the bugs. This is a CPU update. That means companies that offer CPU updates, they have more stuff to do. They have to create both of these updates. That's the reason why you have to pay for it, because that means it's a lot of work to create these updates, because you have to fulfill the TCK. Again, we will come to the TCK. And then again, this happens in October. So this is usually the cycle that we see. It's always these 4 months in the year. That means in October, we will get the first update for JDK 23 that will be released tomorrow. Always when you have a release, it's always in September. The next month, we get the first update. Because especially in the beginning, you have a lot of bugs that's still in the JDK. Okay, that's the CPU PSU thing. And the CPUs, you probably won't find them on the websites. Because I already mentioned, they're always 3 months behind PSUs, but they're way more secure because they fix already these bugs that happened in the last 3 months. And you might think, yeah, I never saw a bug in a JDK. Well, yeah, probably you're not, but it happens. And I have an example. So all of the distributions give you the PSU updates because that's the public available stuff, right? Critical patch updates only from Azure, Bellsoft, and Oracle. No other company offers this because it's a lot of work. And I will explain it when we talk about the TCK stuff, why this is so much work to do. But some companies, especially banks, insurance companies, they need to use CPUs sometimes because this, by their law, I don't know. But we have customers, they say we have to use CPUs because otherwise we can't really use a JDK. They have to use the most safest version. So that means the recommendation for these companies, if you have really mission critical stuff that has personal data involved, then it's a good idea to have a CPU in production. But like I said, this is not for free. And here's an example. This is back JDK 8, but JDK update 252, that was a PSU. And they added some little features, and these little features that they added, they prevented Hadoop cluster and Solr from running. So if you updated to this PSU 8.252, then Solr and Hadoop didn't work anymore. There's probably nothing you have in small companies, but big companies, they really suffered from that. And that means you can then say, okay, we can go back to the last one. But that means you open the door for issues, right, that have been fixed in this one. If you instead went to 851, which is the CPU, that's the naming scheme, right? That worked because this only had the fixes and not the features. And that's why it makes sense to have these CPU updates. This is just one example. We have a couple more of them. So this stuff just happens because you never know, right? So we are just, all of us are just coders and humans. So there's always some problems. Okay, now that's the interesting thing, compliance. TCK, who knows about the TCK? 1, okay. 2, okay. So the idea behind the TCK is, and it makes sense. So you saw OpenJDK is open source. You can download the source code and build it, give it a name, and tell, this is our new distribution here, look. And people might use it, but because you build it from source code, you can change the source code before you build it, right? How do you make sure that it's still compatible to Java? Because Java has a spec, the Java SE spec. Exactly, this is the TCK. The TCK is more or less, it's licensed by Oracle. It was originally developed by Sun. And it contains the tests. The TCK is not the test itself. And yeah, it's licensed by Oracle, I said that already. And for example, for Java 11, it was more than 120,000 tests. And what they do, these tests, they test not stuff like applications, they test the implementation of Java itself. They make sure that a map works like a map, and that a string is a string with all these features on all the platforms. And if you would like to be compliant to the TCK, then you have to make sure that for every distribution, for every operating system, you have to make sure that you pass this test. So that means if you have to do it on Windows, Mac, Linux, specific Linux derivatives if you have them. And then you have to test all the things that Java can do. That means you have to test stuff like Bluetooth because Java can do it, CD-ROMs, printers, sound cards, all this stuff you have to test on all these platforms to be compliant to the TCK. And you can maybe imagine what it means. If we have to create an update, and we have to do that for all of the updates, then it takes a week to 2 weeks for one update to do that. And the same again for the CPU updates. That's a long time. And that's a lot of work we have to do, and you need a lot of hardware to run all these tests.
Question?
Yes.
Are these tests automated?
Yes, you can run them. You can run them automatically. Yeah.
Clean and store.
It
takes 2 weeks.
I've started it once on my machine, and then after I think 1.5 hours, I was like, it's not so important. I believe it will work. So because these tests, they are defined in the so-called JCK, and sometimes you will find. Like it's the same with the CPUs. So we have customers, they say we only allowed to use a TCK compliant JDK. And that makes sense because if you don't use it, that means your application might break because the JDK that you use is not compliant to the TCK. And that means some of these tests might fail. And if you use some of this stuff that failed, then your application will fail, right? This is the idea behind it. So that they are defined in the JCK. The JCK is the Java Compatibility Kit. And this Java Compatibility Kit, you'll find some companies, they say, we are JCK compliant, which is the same as the TCK. I think the Dragonwell, they say JCK compliant instead of TCK. It's just that you know these two terms because you will find them. And as soon as you see they are compliant, then that's a good sign. The bad thing is everything's based on trust. Microsoft say, yeah, we are TCK compliant. I know the manager of the Java team because he was a colleague of mine when we have been at Oracle. And I asked him if they do all the tests. He said, yes, sure. So, sure, we do. So it's they test one of the JDK, it works, and it will work for all the others too. So it's in the meantime it's better. I know they do better now, but in the beginning it was like, yeah, we're TCK compliant, and then they just tested it on some things. But still, I mean, they are at the meantime. The difference there is they have Microsoft JDK because they also have Azure, and they don't want to rely on any other company. So they asked us, when they came out with Azure, if we can build a JDK for Microsoft. And they said, if you build it for us, you can also use it for yourself. This is Zulu, what we have today. We did that for Microsoft, and then they used it for a couple of years, and then they decided, I think 3 years back, they decided, we would like to have our own stuff. Then they built their own Microsoft JDK, because now they have a bigger Java team. So, and the JCK, it tests features that are likely to differ on different platform implementations here, also on different operating systems. So what you have to make sure is that, because if you have an ARM Mac and you have an Intel-based Linux machine or Windows machine, that means the operating system handles stuff differently on these machines, right? And also the hardware. So you have to make sure that Java behaves the same on all these platforms. These tests, that's what they are good for. So stuff that is difficult to port between platforms, like the Bluetooth thing is really terrible. Did someone ever did Bluetooth with Java? This is terrible. And stuff like this. And also they mask or abstract hardware behavior or operating system behavior to make sure that everything is really the same on all platforms, because this is still this write once, run anywhere should work, right? So this is the JCK that makes that possible, but takes forever. The question is, how do you get access to the JCK? In principle, you can get it for free. You have to ask Oracle. Then you have to sign the OCTLA, which is the OpenJDK Community TCK License Agreement. Lots of paperwork. And you have to sign the Oracle Contributor Agreement. More paperwork. But if you do that, you get all the tests. Except your IBM, then you don't get it. Because the difference here is that IBM is not really, it's not OpenJDK. So what they did, there is a spec for Java, and there is a spec for the JVM. And IBM was the only company, they said, we built our own JVM. We just follow the spec. So that's the reason why you can run your Java code also on an IBM JVM. It will work. And that's also the reason why it's different, right? It has better startup behavior, smaller footprint. It's not that performant all the time. But that's the reason why Oracle said, this is not Oracle, this is not OpenJDK, so you have to pay for it. That's the reason why we have Samaru certified, because they needed this TCK compliance to sell it, right? The people, some companies need the TCK. Okay, but if you do that, you can get it for free. So I have it on my machine for JDK 11. It's huge. And like I said, I tested it once, but after 1.5 hours, I just stopped because it takes forever to run through that stuff. And the next thing is, just because a company says, we are TCK compliant, doesn't mean all their distributions are TCK compliant, which is another tricky thing. For example, if you take a look at this one, this is JDK 8, right? You see Bisheng, which is Huawei, Dragonwell, Coretto, and these others. It's not 20 anymore, right? So these are all compliant to the TCK in JDK 8. If we now switch to JDK 9 and above, because now we have the modular JDK, then you won't see Dragonwell and Bisheng because they are not compliant. They have JDK 11, 21, but they don't have the TCK. They don't pass the tests because they added stuff to the source code that they need. For example, Dragonwell, they needed something for Alibaba Cloud. So they added stuff, but this stuff breaks the test. So they can't really claim it's TCK compliant. Of course, they don't tell you. On the website, they just say, we are TCK compliant. Yes, for JDK 8, but not for 11 or 21 or 17. That's the tricky part with this TCK stuff, right? You really have to dig into the details to figure out which companies are really TCK compliant. And it's not enough to just say we are, because for some of these, they are not. Okay. And you see Microsoft is, and they are absolutely. Oracle, of course, and then the others too. But still, this is not all the 20, right? It's not all of them are TCK compliant for JDK 11 or 9 and above. Another test suite is Aquavit. Did someone hear about that? And it's not the drink. It's the Adoptium Quality Assurance Vitality and Speed Test Suite. What a nice name. It's by Eclipse. And when the Eclipse Foundation came out with Tamarin, which is the successor of Adopt OpenJDK, they decided, because of all the hassle with the TCK, because they didn't get it as it was Adopt OpenJDK, Oracle said, no, you will never get it because you have OpenJDK in the name. And because of that, they said, we will also create a test suite, just to have something additional to the TCK. But this is a different test suite. This ensures that all additional qualities are present and that it makes it suitable for production use. So they test applications and use cases. Make sure that it really works in real world situations. And they have more than 350,000 tests. And if you would like to pass them, these tests, or would like to be Aquavit compliant, you need to be also TCK compliant first. So this is also something that people don't know. And if you know the Adoptium website, there's the Adoptium Marketplace. And all the distributions that you can download there, they are TCK licensed and Aquavit licensed. And there you can see that Alibaba and I think Bisheng is not for JDK 11 because they see you can download it only for JDK 8, but you can't download it from the marketplace for JDK 11 or 17. So this is the Aquavit test suite. And it's designed to test real-world utilization patterns, and also it's a suite for security and durability tests. And these are the companies that are really compliant to the Aquavit test suite. These two only for 8, right? Because they don't have TCK for 9 and above. So that means it's more or less. And I think IBM is also now. They also fulfill it. I don't know why. Tamarin. No, I missed it. So IBM, so Semaru should also be on this list. This is Aquavit. Yeah. I never ran the test. So, okay. Oh, now I see my mistake. This is for JDK 8. I made a different slide for JDK 11. This is for JDK 11, and there is Semaru certified because this is it's TCK compliant, and with this it's also Aquavit enabled. And this is the Adoptium working group, and companies that we are also in this working group. That means, for example, because Tamarin is built by Eclipse, and Eclipse is just a foundation, so it's not really a company that can give you support. We offer also support for Tamarin, which is one of the reasons why we are in the Adoptium steering committee. And so is Red Hat, Microsoft, and Semaru. You can also get support by IBM for Tamarin. And Red Hat also offers it, but Red Hat and IBM is the same. All right. So recommendation, in production, it's really a good idea to use a TCK licensed JDK, just to make sure that everything will work. Because otherwise, if you use, for example, Alibaba and you run one of these problems, then it's not easy to change a JDK in a company. So it can be a hassle to convince management that you have to change. And they say, oh, it's the same. It's not. And then, we have these customers. It's terrible. Next point, cost. We have free versions of OpenJDK distributions. And these are all the free versions. and you see there are some little asterisks on there, GraalVM and Oracle JDK, because they are free for 3 years, which is a very interesting move. Last year in January, they changed their, not the license, but how they calculate the cost for the license, which is very interesting. So what they do is they give you JDK 17, it started with JDK 17, they give it to you for free and say you can use it in production, no problem. But when the next long-term support version comes out, then you have to switch to this one, otherwise you have to pay. That means if you're on 17 and 21 comes out, you have to switch to 21. Afterwards, if you don't do it, the next update for 17, you have to pay for it. And the smart move was they moved away from paying per core, but they said, you know, that's so hard to calculate all the costs. Instead of using the vCores that you use in your production system, you just have to pay by the number of employees of your company. And to make it easier, we also, for the number of the third parties that work with you. So that means if you take a customer like Mercedes-Benz, you pay for all employees, also the people that clean the rooms, even if they don't use Java. And not enough, because Bosch is a third-party vendor that works with Mercedes-Benz. You pay also for all employees of Bosch. That's how they calculate the cost for Java licenses now, since last year, January. And you can read it. It's somewhere on the website, very small. And that led to the fact that we had customers, they came to us and said they got a bill from Oracle, which has 5, so it was 10 million or more on license cost because of that. They are not behind small companies. For a small company, it could even be a benefit. Let's say you used your 10 developer shop, but your application uses thousands of vCores. Then before you paid per vCore, and now you only pay for the employees, which is 10, which is very cheap, right? But for the big companies, it's a huge difference because suddenly they don't pay for the vCores, but they pay for the employees. And if you have these huge companies, then that means a lot of money. So that was a smart move from Oracle to do that, changing this license stuff. It's not the license itself, it's just how they calculate the cost. Yeah.
But the cost is only incurred if you don't upgrade to the next 8 years, did I understand it?
Yes, that's the problem, because if you are on Oracle JDK 17, let's say, right? And you're on, I don't know when it switched, JDK 17 or whatever, 5, let's say. Then that means when 6 comes out, 3 months later, it contains all the bug fixes, right? And you know, it's not easy for a company to change from Oracle to another company, to another JDK. So the easiest thing is, we pay for it. And then you can just update to the next version. This is what they hope and what happens. We had that with one customer. They said, oh no, we have to change. And then we have been in negotiations with them, and for them it was so hard. And then after half a year, they said, you know what, we just pay for it. So they just pay the cost for Oracle because it was so hard to change internally to a new JDK vendor. Which is, for big companies, that's really an issue. So they are not allowed to just change this because they have to be TCK compliant. You have to approve all this stuff. And then, most of the time they run out of time. That's one of the problems here. But this is the new licensing for GraalVM also. So Oracle JDK and GraalVM. And another smart move was that, I think it was last year when they changed it. On the website, when you go to the GraalVM website and you say, I would like to download, then it was GraalVM Enterprise. And it says, for GraalVM Enterprise, you have to pay. And there was GraalVM CE, which is Community Edition. What they did, they moved GraalVM Community Edition to GraalVM Community. And this you can only download from GitHub. And GraalVM, which was formerly GraalVM Enterprise, this is now GraalVM. This is the stuff you download from their website, because it's free in production for 3 years. After that, you have to pay if you stick to this version. So it's really some tricky moves that they do. So you have to be careful if you use GraalVM. This is also the reason why if you use, for example, Spring Boot Native or Red Hat, the Quarkus stuff, they don't use as far as I know, they use GraalVM Community because of this. They can't just use the GraalVM Enterprise because then 3 years later, customers might go to the next version, I have to pay suddenly. Right? It could be tricky. So as far as I know, they use the community version. Okay, then we have paid versions. Our own platform Prime, which is a specific JVM. I will explain it later what it contains and why you have to pay. There's now you have to pay on number of cores that you use, right? This is the typical thing. IBM Samaru certified, you have to pay for that. And GraVM, which is the now formerly enterprise version. Like I said, this is now based on number of employees. And the same for Oracle JDK. After 3 years. You have to keep that in mind. You can use it for free for 3 years. And now performance, that's probably the most interesting part. Because what do you expect if we have more or less 20 different distributions and they all build the same source code? This will be a huge difference, right? So we have the baseline performance, right? And this is more or less the same. Even Samaru, it is sometimes faster, sometimes slower, but in principle, it's not really breaking different, right? So that means it doesn't really matter which of these JDKs you use. And I also count in the GraVM community stuff as the JDK because they also they have a JIT compiler, right? Libraricanik. I don't talk about the native image stuff here. But if you use Java code compiled with one of these JDKs, performance is more or less the same. It's not really different. Yes, sometimes it might be 500 milliseconds faster here, a little bit slower there, but this is not really record-breaking, right? So it doesn't really change the world. So that means if you just aim for performance, take whatever you like. If it's based on OpenJDK, it's fine. It's fast. It's okay. If you need really high-performance stuff, then it's different, right? So that means this is more or less all the same. But if you need high-performance JVMs, because there are some, then we have to take a look at the JVM first. Because if it's more or less 3 parts in the JVM. We have the class loader subsystem, JVM memory, and execution engine. And in these parts, again, we have then for loading, linking, initializing, and JVM memories, also different areas here, right? And the interesting part is in principle the execution engine. This is where the interpreter sits and the 2 JIT compilers, profilers, and garbage collectors. And then also some native memory stuff. So and if we take a look at the execution engine, then we can exchange things here. We can exchange the compiler and the garbage collector. And with this, you can create a faster JVM. For example, this is what we do. We wrote our own compiler and just replaced the compiler in the OpenJDK with our own compiler and also our own garbage collector. And that makes this JVM faster, and this is also the reason why you have to pay for it, because we developed this stuff and we can't give it away for free. And the same is true for Oracle GraVM, the enterprise version. Their compiler is also quite fast, the code that it creates, right? So this is, and this is probably also the reason why you don't get this stuff in the community edition, because there's a huge difference between these two if you compile code with them. Features, this is another point where you can make differences between the distributions, because I told you, we all take the source code and add features that we need, or that we need for other products like Azure, like AWS or Alibaba Cloud. So they add stuff that is beneficial for their other products. First of all, Amazon Corrado, which is of course just a build of OpenJDK, but they have Snapstart, right? Who knows what that is? Snapstart Firecracker. So if you work with Lambdas, then you probably, if you don't know it, then take a look at it, because this is more or less made for make Lambdas fast and not that slow, especially when they're cold. And that's the biggest difference. They have some other stuff, especially for AWS, but this is not really world-changing, so it's not worth talking about it. Alibaba Dragonwell. They have Alibaba Cloud, which is really huge in Asia. And they have 2 different versions of Dragonwell, the standard and the extended edition. And they have JWarmup. And the idea is, that's quite interesting, because the original idea was developed by Azul in OpenJDK. Then we figured out it doesn't work with OpenJDK, so we stopped it. They took the code and created JWarmup. Because it doesn't really work, this is one of the reasons why they break the TCK test. And because we figured that out and we stopped working on OpenJDK, and that's one of the reasons why we have our own compiler where we can do this stuff without breaking the JDK. So, but the idea is you start your application and all the compilations that are done, you save the optimizations that you did to all the methods. Sounds like a lot of stuff, but it's not that much. And then the next time you start your application and the method will be called by the interpreter, you directly know, oh, the last time I optimized this method in that way, and you can directly do it. You don't have to, because if you know how the JVM works, it's some kind of an iterational process. So first it's interpreting, then we have the C1 compiler, creates very quickly code that is at least compiled, but not optimized. And if this code is called a lot, then it will get into the C2 compiler, and this is then finally the very fast code. But this process takes some time. To save this time, if you just know exactly what was the best optimizations that I did to the method, then you can directly compile it with this kind of optimization. That was the idea, but it kind of works in JWarm-up because in OpenJDK it was not that easy to do. It's mainly because of the C2 compiler. Then they have something called Elastic Heap, where they can return memory from the Java heap to the operating system. And they have Wisp too. I didn't find more than stackful symmetric coroutine at JVM level, but I have no idea. I didn't find any more information. The problem is all this stuff is in Chinese, and then you trust just Google Translate and hope it's correct. But yeah, I didn't find any good examples what it can do. But that's Dragonwell. Tencent Kona, yeah, nobody knows, right? Tencent is huge. And what they did, they are specialized on embedded, especially on ARM. So they do a lot of embedded stuff on ARM boards. And what they, for example, they have Kona fibers, which is more or less Loom. But they have it in JDK 8 and 11. And it's faster than Loom. So they have test code on their website. I think it's on GitHub, or it's the Chinese GitHub, where you can test JDK with Loom, so virtual threads, right? And you test it against Kona fibers, and Kona fibers is faster. So for example, if you work on embedded stuff and you need it in JDK 8 or 11, then Tencent Kona is a good idea to use that. And in this one, they also have the TCK, so in 8. So this is Tencent Kona. Oh, they also ported ZGC for ARM. ZGC is a garbage collector in the JDK. And they ported that for ARM because, like I said, they are mainly on ARM architecture. Okay, this is Tencent Kona. A Bellsoft? Who knows Bellsoft? Who's working on Spring Boot? Okay, this is the default JDK that comes with Spring Boot. So Liberica is their JDK. And they have a version, they have a version that comes bundled with JavaFX. So you can, if you like, then you can get a version that is like JDK 8, where JavaFX was bundled. It was never part of JDK 8. But with Bellsoft Liberica, you can get, for example, JDK 21, and it feels like JDK 8. So it comes bundled with JavaFX, and it's already set up. So you don't have to add some dependencies or stuff. Okay, that's Liberica, that's their JDK. And then they have Liberica NIC, which is Native Image Kit, which is their build of GraalVM. And there they have the same. So this is a GraalVM version where you can get it bundled with JavaFX, and you can create native desktop applications, not mobile, just desktop, using JavaFX with Bellsoft Liberica NIC. This is, now Gluon also does it, but yeah, this is the only other company that did that. Yes, native desktop apps. Yes, I said that already. And then we have Gluon GraalVM. Who knows Gluon? So Gluon is, it's a little bit problematic because it's not so easy. It's more or less a 3 or 5 man show. They took GraalVM in the meantime, and before they did a different JDK build. And they can build native applications that run on iOS, Android, ARM, and desktop. So you get a native image, like an executable, that you can run on your iPhone, for example. And it works. So I did that for a couple of years. Yeah, native desktop apps. including ARM, that means Raspberry Pi, for example, Android apps, and also iOS apps. And the idea was to build native applications that look the same with the same source code for different platforms on mobile. The problem is that Android's applications, first of all, look different than iOS applications, and also the UX, so that means how you use applications, is different on Android than it is on iOS. So on Android we have this floating button, it's not available on iOS, and these kind of things. So that means if you create an application that should behave like an Android application, then it's more or less easy because the default UI scheme comes in an Android look and feel. On iOS, you don't get it. On iOS, it also looks like an Android application. So it's not really that nice. And that means if you would really like to create a native iOS app, I wrote a Apple FX library that covers some of the controls to make it look more native. But it's a lot of work. And so that's one of the reasons why people don't use it, because in the end, you have to do the UI again separately. And then the logic most of the times is not that big on these mobile devices. It's a lot of graphic stuff. But this is, at least it's available, and you can build native applications for these platforms, which is nice. Then we have Oracle GraalVM, not the Community Edition. They have Community and Enterprise. It's a polyglot JVM, so that means we have JavaScript, Python, R, and Ruby, and you can all compile that down to native images. The GraalJIT compiler is a replacement for C2, which is the compiler in the JVM that creates all the optimized code. And it was rewritten in Java. That was the main idea behind GraalVM, is this idea. This is how it started. Because C2 it was created by Sun, and then it was further developed by Oracle, and it's a hassle. So nobody really would like to touch it because it works and it's good. And the GraalVM lab, or it was the Oracle Labs team, they decided if we rewrite the compiler in Java, it's way easier to maintain in the future. And that's how GraalVM started, right? That was the beginning. And now the compiler is really good. So the GraalJIT compiler is quite fast. And then they have an AOT compiler, which is a different thing, right? This is a compiler that takes the Java code and compiles it to binary, so to native code, machine code. Sounds cool, gives you very small images to start with. The problem is debugging is not Java code anymore. So you have to debug native code. And if you're not used to it, it's not easy. And there are also not really the right tools available at the moment. They are working on stuff, but it's not really there yet. But it will come probably. IBM Samaru, yeah, I already mentioned that. We have the Community and Certified Edition. You know why it's certified now. It's not free. The OpenJ9 JVM, this is the counterpart of OpenJDK. This is the stuff that IBM wrote. It fulfills the JVM spec. So it's JVM like it is specified. It has faster startup and lower memory consumption. So, and they have also some nice features, like they have an AOT compiler, which is not the same that GraalVM has. So they name it dynamically compiled AOT code. I talked to them and they explained it to me, but I already forgot again. So it's not really that they compile all this stuff. I think they compile often used methods and then they directly can use the compiled code. But I'm not quite sure about that. But it helps with startup, definitely. That's the idea. They have Instant On, which is more or less crack. So I will explain that in a second. So that means checkpoint and restore. So if you have a notebook, like a laptop, and if I now close the lid, then it will go to sleep, right? So the computer will shut down. And when I open it tomorrow, everything will be there. That means that probably it won't run in presentation mode, but Keynote will be there. This is checkpoint restore. When I close the lid, the operating system detects, oh, it's like a switch. Oh, I have to shut down. Oh, there's application stuff running. I save everything to the disk. And the next time you open the lid, operating system boots up. Oh, there is a checkpoint and just restores everything back to memory. So that it feels the same as when you left the machine, right? This is checkpoint and restore. The idea is to do this on the JVM. So you start your application, you run it, you stop it, create a checkpoint, and you just start from there. Why won't you like to do that? Because startup of the JVM takes some time because you have to interpret and compile and optimize. And before the code is fast, it can take some seconds, sometimes hours, depending on the application. With this, you just have to do it once and you just stop the application. And when you deploy it with this checkpoint, which is a set of files, it's a heap dump. And then you can just load that back to memory and it's directly there. It's as fast as native images startup, but it's just a JVM running. That's the idea behind instant on or crack, which is the same. Just this is working on OpenJ9 and crack is on OpenJDK. And they have a JIT server, which is also an interesting idea. So if you have a server machine, then you have a couple of microservices. They run in a cluster. So if you deploy that, then usually every service comes with a JVM, compiles the code, runs it. If you now, instead of compile it locally in the node, tell the JIT server, I have this code, can you compile it for me? The JIT server says, sure, I compile it and give you back the compiled code. Takes a little bit longer in the beginning, right? When the second service, when you scale up, the second service, the same request directly gets the compiled code. It means if you have lots of services and you have to scale up and down, this can be way faster, right? Because the JIT server keeps all the compiled code. And if you just ask for a method, you get just back your compiled method. And if it's in a cluster, it's quite fast. That's the idea behind JIT server. So it's a remote JIT compiler. That's the idea behind it. Microsoft JDK, they come up with No Escape, which is an experimental feature to decrease latency and improve throughput. I think in the meantime, it's part of the JDK. It's not experimental anymore. But this is only available in Microsoft's build of OpenJDK. So that means they added code, compile it, still TCK compliant. So this is No Escape. This is Azul Zulu. Yeah, this is our build of OpenJDK. We also offer bundled with JavaFX. We have also vulnerability detection inside of it. So that means we can detect at runtime. The JVM will talk to another program, which is a forwarder, and this will talk to a cloud service. And then we can tell you at runtime if you have vulnerable code or libraries, for example, and we can tell you if you use it. That's the big difference. Because if you have a vulnerability scanner that you should have if you run in production, then usually what they do is they scan up to CI/CD builds, but nobody's scanning in production because usually you need an agent to do that and that takes time, so it drags down performance, but we can do that in the JVM. And we don't have this performance overhead. And we can tell you, oh, you have a dependency on Log4j. Oh, this is vulnerable, but you never used it, so you're fine. And the scanners can't do. They just tell you, oh, you have a dependency on Log4j that's vulnerable. I can't build it because it's vulnerable, right? We can tell you if you use the stuff. And we have code inventory, same thing, because we work on a JVM. The JVM knows exactly what classes you load at runtime. So we can tell you, you know what, this code, you load it, but the other classes you never loaded in 6 months. So maybe you don't need it, right? Because it was never used, it was never compiled by the JVM. So this is also possible using, we name it Intelligence Cloud, it's a cloud service. Then we have crack, which is coordinated restore checkpoint, same stuff that I explained for Semaru, right? So we invented this stuff for the OpenJDK and works exactly the same, like closing the lid and open it again. And the last one is this platform prime that I already mentioned. We have a different compiler, which is based on LLVM, and we just replace C2 in OpenJDK. So this also fulfills the TCK. Even if we have a different compiler, we pass all the tests. And this is one of our expertise because we did that already 11 years ago, or even longer, because we built the compiler and other stuff in hardware. So we have been a hardware machine in the beginning. And I think 2013 or 14, if I'm right, we had already machines with 780 cores and I don't know how much terabyte of RAM. But then at one point we figured out, okay, we can't compete with Intel and all these big companies. So it's better to put the stuff in code. So that was the beginning of this Falcon compiler and also of the C4 garbage collector. By the way, ZGC in OpenJDK is a copy of this collector. This is more than 12 years old. And we have a paper and everything is described in there. And ZGC is a one-to-one copy of this collector. So it's, yeah, they figured out that they can just recode it. Then we have ready now. This is the same stuff that Alibaba used, this J warm-up, where you run your code, the compiler does all the optimizations, and we just note all the optimizations that it did. The next time you start up, it just compiles it directly. So there's no interpretation or C1 compilation anymore. It goes directly straight to the Falcon compiler. Cloud Native Optimizer, same as the WebJIT from IBM, is the same thing, just on OpenJDK. So we have a compiler in the cloud, a server, and then the services just talk to the compiler and tell them, I need this method, give it back to me compiled. And the same as we have this vulnerability detection and code inventory. So this is also available in Prime. But this is not for free because of all these features. And to be honest, this is really something, if you suffer from cloud cost, for example, you probably know Walmart, right? They switched to Prime on all their installations and they saved more than $10 million just on cloud cost stuff because of this. Because if you have a compiler that can produce faster code, that means you don't need as many CPUs. You can save CPUs. And this is really money in the cloud. And that's why this is good for cloud cost optimization. So this is mainly for big companies. They have huge cloud costs, so they will benefit from this JVM. And we have Greg, of course we have. So the takeaway, I hope there was something interesting for you. See, all these builds of OpenJDK, are they really different? Nah, technically not. But if it comes to service support and costs, then yes. So there we have differences there. And you as a user usually don't care. Most of the times you don't even have an influence on your company's decision which JDK they use. But if you stumble upon stuff like, oh, we are still on Adopt OpenJDK, now you know it's a good idea to change, right? So don't stick to old JDK releases. It's really not a good idea, especially not old updates. So you can stick to JDK 8, install the latest update, 11, 17, 21. Please do yourself a favor and download the latest update, because I have another session just about security in the JDK. And you will be surprised how many open issues there are if you don't update. For example, from JDK 17, I have to lie, but I think it's around, if you go to 17.0, the general release, and you never update with an update, then today I think it's around 70 issues that are open, security issues. So that means with every release, with every update, you get up to 10 new security vulnerabilities in the JDK. So it's a good idea to update this stuff. Yeah, choose wisely when you select the JDK. And with this, I'm done. What's the time? Oh, it's good. And if you have questions, we can talk about it now. I have to be honest with you, this is not my favorite topic, right? Because this is very dry. But I figured out that people, when they come to our booth, they have no idea. They use whatever they have on their machine. They don't know which update they have. They never heard about CPUs and other stuff, TCK. But I think it's a good idea to have at least some knowledge about this stuff, because if you go higher up in the management, this is a good idea to know about these things. We have lots of customers, they have so many discussions and conversations about security and updates and TCK, and it's terrible. But that's the way it is, especially with licenses. Yeah, it's good to know what's going on. Okay, if you have questions, feel free to just shout it out. Yeah.
So, first question, the J-Link JRE you mentioned, with this small footprint, I find this interesting. And how is it compared with the Grail VM native image?
Okay, give me a second. I have a slide for you. Because I did that, it's in this session. I did a session about crack, which is this coordinated restore checkpoint. And in this one, I compared, there it is. So That's a Spring Boot application, right? And the Spring Boot application took 4.1 seconds to start up. That's the native image with Spring Boot native, right? It took 500 milliseconds. Okay, cool. So with Crack, and Spring Boot has a so-called automatic checkpoint. We don't go into details here. Then that means you don't have to change code, right? Then you get 700 milliseconds. And it's still Java. It's not a native image. If you manually tune it, you can get down to 300 milliseconds startup time. But this is not your question. That comes now. If I have the standard stuff, the jar file was 57 megabytes. If I put it with a JRE, it's 207 megabytes for this combination. If I use a JLink runtime, it was 127 megabytes. The native image is 185 megabytes. But this is with a checkpoint, right? This is the checkpoint. You also have to add this one. And that leads me to, a checkpoint is in principle, you take the heap with all the objects in there. We do a very aggressive garbage collection so that it's really only the live objects. And then we save this to disk, right? It's a binary format, but uncompressed for this application was 160 megabytes. We can compress that to 40 megabytes. That means this is where you end up. Even if you use a jar file with a JLink runtime and a compressed checkpoint, it's smaller than the native executable with a faster startup time still, even if we have to uncompress it. So you can compete with native image, but I have to say that Spring Boot not really creates the nicest native images. So Quarkus is better. It's smaller and starts up faster even. But Spring, everybody uses Spring, so that's why I use Spring Boot here as an example. This is the uncompressed stuff, so you end up with 367 megabytes. But if you use the compressed thing, it's 167. Keep in mind, if you install it and you start it, this will be uncompressed, right? So it will be, again, 160 megs on the drive. But for deployment, this is the thing. Deployment times are the same. Startup time is more or less the same. And in memory, it doesn't matter if you use native image or JVM, because if you use data in memory, then you blow it up anyway. So does it answer the question?
Yes.
So you can get down to the same deployment size with using native image or JLink. It depends on your application, of course. And the tool that you need is called JDEPS, which is also part of the JDK, like JLink. So if you type it in JDEPS, then it tells you, you just put it on the jar file, and you need a fat jar for that. And then it can decompile it and check all the modules, and then it will give you a list of modules. And this list you can directly feed into JLink to create the JRE.
Is there a Maven plugin for that?
I don't know. I have a shell script that does the same. So it's really just very small. It's a couple of lines. It's not really tough to do that. Any other question? Yes?
It's maybe not a question, but kind of a comment why we don't use JLink. Just, for example, and probably a lot of other companies, they were restricted on base images which they can use.
Yeah.
So they cannot just create own images.
Yeah.
They need to use certified images as well, which already delivered with JRE.
Yeah, that's true. I know the problem. The same as if you're a Red Hat customer and you are on Red Hat Linux, then it comes with Red Hat's JDK and Red Hat JDK, and then you have to use it. So I know that there are restrictions, but there are also a lot of companies where you can choose, and people just don't do it because they don't know. Some people just think, oh, if I use this, then I have to use modules in my Java application. No, you don't have to. So you can use the class path. It's just the JDK. And it makes sense to shrink it down. So why deploy 150 megabytes if you can get down to 60 or 70 megabytes? It just makes sense.
Are there some known issues that JDEPS doesn't find some dependencies
Yes.
at runtime?
Yeah, not at runtime. The problem is the JDEPS tool is not for runtime. This is really just you analyze jar file. And the problem there is, especially if you use Spring Boot, for example, it just finds Java base. Because Spring Boot the structure is not very nice. So also the fat jars it creates can be really, JDEPS can't really read it. So what I did is, in my script, I just unpacked the jar and run JDEPs on all the jars inside. So you have to find workarounds, but it's possible. It's just a little 1 or 2 steps more, and then you create your list of modules from there.
You mean those jars which are mounted into the lib?
Yeah, this is easy to find. If you have a lib folder with all the jar files, you can just run JDEPs on all these jar files. The problem is if you have a fat jar from Spring Boot, because if you compile it, you get 1 jar. In this jar, it won't work. So you really have to unpack it and then run the JDEPs on all the jars in the lib folder. Yeah, that's the problem.
But this probably also should be recursive because there might be other jars which also make it.
It works, for example, when you do it manually. I created a fat jar using, what's the name of it? There is a Tengelmann, something like that. There's creates a fat jar. If you use this one, then it works. So it's really, this is a Spring Boot thing. So if you use the Spring Boot jar, it doesn't really work. But like I said, it's not really, I did just, last week I did it because I had the problem with a colleague and he said, I just get Java base when I use JDEPs. And I said, okay, yeah, it's a Spring Boot application. You have to unpack the jar file and then run it on all jars, which is a different thing. Anything else?
How do they differ in open source licenses? So in my specific case, we want to sell a hardware product with a JRE on it to run our application. Which one should we choose?
Which JDK or JRE? You can choose all of the free ones. Don't use the Oracle one. They say you can use it and you can, but as long as you use, you can use all of these, right? Of course you should use Zulu, right? Because it's the best, right? The best of the builds. You have the nicest servers. Now it doesn't really matter because OpenJDK allows that to do it. And if you use JLink, the same. So it's because this is just, you just strip it down a little bit. But if you use OpenJDK or build of OpenJDK, it doesn't really matter. So the licenses is GPL2, which means it's with the ClassPass exception, so you can use whatever you like to distribute, no problem.
Thanks.
Anything else?
Yeah, one
Sure.
concern I have with JLink, which is the reason why I never used it, is it's probably mainly meant for enterprises, because if you distribute a small application, the JDK is usually some operating system infrastructure. So it should have all the modules. It would not make a point. There would not be a point in having 5 custom JREs, because every app.
Yes, it makes sense, absolutely. Because why would you deploy modules that you don't need? That's exactly the reason why you have JDEPs. That figures out what your application really uses from the JDK. Why would you deploy other stuff just because maybe you use it in the future? Then you run JDEPs again and then you get another module. It's smaller. This is the main idea.
They can really add up, and the users would have.
Yeah, of course. You just create it in your build process. You just create this. It's copy files. It's very fast. It's not really compiling stuff because you need a JDK to create a JRE, right? So what JLink does, you take JDEPs and say to JDEPs, check this jar file. And then it will tell you, oh, you use Java base, you use JavaNet, whatever, right? It gives you a list of modules that you use from the JDK. And then you can directly pipe into JLink, and then it copies the stuff from the JDK folder in a new folder, and that's it. And that's your JRE. That's all you need. So it's really, and if you decide in the future, oh, now I need also whatever module, right? You just add the dependency. And then if you're in your build process, it will just figure out, oh, there's a new module and add it to the JRE. So building the JREs, it doesn't really take long. This is second. Yes?
I just found JLink also beneficial from a developer's point of view to stumble across dependencies that you didn't think you had.
Oh, yeah.
And then you investigate them, and it's quite motivating to find maybe there's just this one link that you can do away with.
Yeah.
And you can make your application better.
And that's an interesting point, because this is why we built this code inventory stuff, because you know how developers are, right? So it's like you have to, a manager comes to you and says, oh, you have to do matrix multiplication here in this part. And you say, oh, yeah, I learned that once. I have no idea. You ask your colleague, you say, oh yeah, there's Apache Commons. They can do it. Oh, cool. You add the dependency, bam, you use one method. But you add 200 whatever methods to your application just because you need one. And everybody knows that. Everybody does it. That means you blow up the whole application because you are too lazy to just write the code yourself, right? And then in the end, it's exactly like you said. We have, for example, Netflix as a customer of ours. They came to us and said, if you can build a tool that can tell us what code we really use, we will buy it. So they bought it. We just built it for them, more or less, right? So now, but everybody can use it now. It's this code inventory. Because they say we have so many dependencies where people just use one method in one class. And we would like to shrink it down. And so that's exactly, and this is the same if you use JLink because it tells you the dependencies. That helps you at least on the jar level. Auto can tell you in the method level and can tell you, okay, you use this one method in this jar. And then you can just extract it. But this is, you're totally right. It's interesting to see what dependencies you have in your application because it lists you all the stuff.
In addition, we've had several situations where we just wanted to work with a later JDK or JRE and didn't have any way to upgrade the corporate JRE that's on everybody's desktop, which is usually Java 8. And so we wanted to distribute stuff, Java 21 or 17 based, and so we had some bootstrapping to bring our own JRE onto the desktop.
Yeah.
And then it's actually a lot of copying you have to do. The deployment is more megabytes to copy, and so JLink is very beneficial.
Yeah, it is. And like I said, because it just copies file from the JDK in a new folder. So what you do is you tell JLink, use these modules and the modules you get from JDEPs, and then this is the folder where you should create the new JRE, and then it creates a folder for you, copy everything over, and then you can just take this folder and this is your runtime. And that's really nice. So I'm always surprised that people never really dig into it because it's out there since JDK 9. I guess it's because all the module thing was, people are just fed over with this stuff like, oh, I can't hear it anymore. Who uses modular applications here? Wow, one. I also use that. But it's right? ClassPass, it was so nice, right? Now we have this, okay, module Java, yeah, nice, and then it doesn't work, and then you need requires, and then you need, but this is, I think, the problem where people hear modules and say, oh no, I don't, not for me. But I think this is really good to use JLink. At least you can take a look at it. And it's, like I said, if you need a script, then just ping me. You probably have my email address, and I can send you the script. It's really just, yeah, it's a bash script. It's not really high-end bash scripting because you don't need. It's really very simple. You just run JDEPs and then get the output and add it to JLink, and that's it. Anything else? If not, then you should drink more because of the empty bottles and full bottles and stuff.
Thank you very much, Gerrit.
Yeah, my pleasure.